All right, so this is 1.6 casting and ranges of variables. And I'll zoom in a little bit so that way you guys can see it. It says it should only take 45 minutes, but I think we've been able to get it under whatever the time is recently. So we'll try to get it under, but still make sure we cover everything. So some of you have already gone through 1.6. I can see that in the guide, but at the same time, I want to make sure that we're all completing this, and also to answer questions as they come up, that maybe there are some things that you don't need to focus on that you get caught up in, or maybe some things that you are skipping over that's really important. So we're going to talk about casting. And first, it starts off and says, in Java, type casting. It's a new vocab word, type casting. We talked about data types, right? But what if you want to change a data type into something else? Well, that's type casting. Think of like data type casting. You cast it into something else, or you convert it into something else. And that's why the first word that's used is convert. It says type casting is used to convert variable values from one type to another. If you have a variable that originally you declare and initialize as an integer, but later on want it to be a double, or it was a double and then you want it to be an integer, you can do that. Okay, so it says it's used to convert variable values from one type to another. By casting, we don't mean something you go fishing with, but it's similar to the idea of casting a pot in clay. I didn't know that. I didn't know that was a term for casting a pot. My wife obviously would be upset that I don't know that, but casting. In Java, when you cast, you are changing the shape or type of variable. Interesting. I didn't know that. And this is a picture of casting a pot in clay. Have any of you guys ever made a pot like that? I've never done that before. Seems kind of cool. I'm sure Ms. Stanza has. The casting operators int and double. Notice that int is in parentheses and double is in parentheses. Are used right next to a number or variable to create a temporary value converted to a different data type. And it shows an example here where 1/3, 1 divided by 3, it's casting it as a double. Because if you have 1 divided by 3 and it's an integer, 1 divided by 3 will return 0. Because an integer, the integer value would be it would cut it off right at the decimal point and make it 0. Maybe we don't want it as 0. Maybe we want it as the actual number. So 0.333. Okay. Ryan, to answer your question, a few classes ago, you asked about doubles and floats, right? And we talked about how, there are different data types, and floats are actually usable in Java. For beginners, I try not to confuse people and offer them multiple data types, but float is a data type and it does take up less storage. Okay, so for example, this will give a double result instead of an int one. Run this code to find how Java handles division and what casting can do to the results. So, we have this double inside of parentheses before the number or the mathematical operation that's about to happen. It says, notice what happens when you divide an int by an int, or an int by a double, or an int casted to a double divided by an int. That's a lot of verbiage, so we're just going to go ahead and do it. Okay, so it's telling us, look at this. This is my main method. Awesome. System.out.print lines. This is going to print out 1 divided by 3. All right, let's just run it and see what our results are. Okay, so 1 divided by 3, it just returns a 0. It assumes that since you gave 2 ints, that it wants an int back. Now, if you have a double divided by an int, right, 1.0, it stores it automatically as a double because of the decimal point. and divides it by 3, and it gives you the actual value. So that's a trick around it. Or the opposite, 1 divided by a double. So whenever a double is used, it's going to store the answer as a double, or print the answer as a double back to you. Naturally, the way Java works. If you have 2 ints, it's going to print the int back. Int being an integer. But check this out. If you just write 1 divided by 3 and you cast it as a double, notice the double is in parentheses. Can't just write print line double 1 divided by 3, double inside parentheses 1 divided by 3. Okay. And one way to think of that is like, think of that as it's multiplied by to create a double, right? So let's say if you're multiplying something by -1 to make it negative, imagine this is you're multiplying it by this imaginary double to make it a double. All right, this is my output. Once again, 0, 0.3 repeating, and so on. So once again, Java assumes that you're doing division with integers naturally. Okay. And that you want an integer result, and it will truncate, which means it will cut it off and throw away the other part after the decimal point, which most of the time you don't want that, right? Most of the time you don't want your program to cut everything off. Can you imagine if we wrote a program with money, right? And then just cut off, oh, it's a decimal. We'll just cut that off, right? We'll just take that person's money away. Right? So it will just cut it off after the decimal point. It will assume that. But if you want a mixture of integers and decimal numbers, which are sort of double, Java will assume that you want a double result. Okay, if you use a double, it assumes double. If there is at least one double in the operation, Java will widen the type of the other operand to double 2. That doesn't necessarily make sense. And return the result in a double. It's basically the same thing. If you have integers and you want a double result from some mathematical operation, we learned how to cast, right? Casting data types, just like we talked about when we cast that pot, we're turning it into something else. So whenever you see the word cast, just think convert. When I was learning one of the introductory programming languages, we learned BASIC, we learned C#, we learned Java. I forget which one. Like I took them all at the same time in college, but they were talking about converting and that being the same thing. Whenever you see the word cast, think convert. Okay, to a double using this as shown above, this double. Values of type double can be rounded to the nearest integer by adding or subtracting 0.5 and casting with int using formulas like the following. Okay, this is where you guys start paying attention a little closer. We have an integer, okay, and we're casting it as, we're declaring it a variable called nearest int, and we are casting it as an integer, putting whatever number is put in. No matter what number someone puts in, we're going to add 0.5 to it, and that will convert it to its integer. Okay, and then if we want to find the nearest negative integer, we're subtracting 0.5, and more on that in a few minutes. Don't necessarily get super confused by that. This is not something that I typically use often in programming, but at the same time, it's something that they want you to learn. So don't get caught up in this. This isn't something that you want to spend a ton of time on. So the question is, if you start off as a double, can you turn it into an integer?
I said double nearest end, nearest end is equal to integer.
I believe it would work, but we can test this out. For example, if you divide 5 by 3 using integer division, Java will truncate 1.67 to 1 to give an int result. All right, that's an integer. However, we usually round up any answer 0.5 and above, right? Think about in math, if you have like 4.5, usually rounds up. In the grade book, if you have an 89.5, it automatically rounds you up to a 90. I don't even have to do anything. Right? At the end of the semester, end of the quarter, it rounds you up to a 90. Anything 0.5 and above. Okay. It says using the formula above, if we add 1.67 plus 0.5, we get 2.17, and then casting it to an int throws away the decimal point, leaving just 2. So that could be a way that the grade book does that calculation. It adds 0.5 to your grade and then will naturally round up or down. All right. Run the code below to see how the formula of adding or subtracting 0.5 and then casting with int rounds a positive or negative double number to closest int. So there you go. Right. So you start with a double and we're able to cast it to the closest int. So I'm going to run this and then we'll walk through this step by step. All right. Let me zoom out a bit. All right. So let me just walk through this code. I have my main method right here in line 3. I created and declared an integer. Sorry, I declared a double named number. And I assigned it the value of 5.0 divided by 3. Okay, so that should give a double result, right? Just because I know that I have at least one double in there. And if you look up here, 5 divided by 3 will actually give you 1.67. So this number is actually 1.67. So if I want to add a comment, something the computer can't read, I'll say, all right, this should be 1.67. All right, that's just how I write a comment. Then I have my data type an int. I'm declaring an int called nearest int, the nearest integer. And I'm assigning it whatever the number was, which is 1.67 plus 0.5, but then casting it as an integer. Okay, so I kind of read that out of order because that's just the way I like to read it. I like to find where the operation is actually occurring and then seeing what I'm doing with it. So 1.67 plus 0.5, right, gives me, as I had up here, it told me that plus 0.5 gives me 2.17, right? So really, this should give me 2.17 and then round it. So it was 2.17, and then it rounded it to 2. Just explaining what's happening in each line. Okay. Then I'm printing out, it says system.out.println 5.0 divided by 3 equals, and then I am concatenating it with this number, right? It will give me 1.67. And then it's truncated by whatever the number was. So if I wanted to truncate it, I would write int in front of the number and it would just be 1. That should be 1. This should be 1.67. And then I'm printing out 5.0 divided by 3 rounded to the nearest int. Right, and it gives me, I'm sorry, 5.0 rounded to the nearest int, and then it gives me the nearest int. What I had here, it should be 2, right? So I'll go ahead and write a comment there saying 2. Then I create a double called neg number for negative number. And I'm taking whatever the number is, which is 1.67, right? And I'm writing it as a negative number. So negative 1.67. That's what the answer should be. And then the integer, I'm creating an integer called nearest negative integer. Okay, so that should be able to round down. So the negative number minus 0.5 to the nearest integer, right, should give me, if I'm subtracting 0.5 and then declaring it as an int, casting it as an int, that should give me -2. Negative 5.0 divided by 3 rounded to the nearest negative int. And then it gives me nearest negative int. And I guess that's where it actually prints out -2. And let's see what it actually came out as. All right. So once again, I predicted that it was going to be 1.67 or 1.6 repeated, right? That was right. And then 5 divided by 3 truncated is 1. That was right. 5.0 divided by 3 rounded to the nearest int. Where was that? 5.0 rounded to the nearest int gave me 2. So that was correct. And then the last one, negative 5.03 rounded to the nearest negative int was -2. So that was correct as well. Okay. And you can always walk through your code and write comments. The computer cannot read the comments. It just goes through and kind of skips over them. It just knows to do that. So if you ever want a single line comment, the 2 forward slashes will allow you to do that. And that allows you to help walk through your code, just as we talked about in the last class. Okay. It says, what happens to repeating decimals like 3.3 repeating, right? That goes on forever and ever and ever and ever. How do we not cut off what the number actually is? And it says Java limits the number of digits you can save for any double to about 14 to 15 digits. So it can only store 14 or 15 digits. You should be aware that the accuracy of any calculation on a computer is limited by the fact that computers can only hold a limited number of digits. So we can get really close to an answer with a lot of decimal points, but we cannot track every single, because if it goes on forever, 3 repeating means it goes on forever. So we can't store an infinite number. Eventually we cut it off. So doubles cut it off after 14 or 15 integers. I'm like, hey, you guys ever like typed something in your graphing calculator and it just stopped it and it put in scientific notation and just said E and then 67 or something, where it's really times 10 to the 67th power, or it just continues moving on and on and on forever and ever and ever and ever. Okay. For example, int values are stored in 4 bytes of memory. Okay. In AP Computer Science Principles, you learn the difference between bits and bytes. I'm not sure how much we talk about bits and bytes and storage in this class. I assume that we have to talk about eventually, but a byte is 8 bits. We mentioned that a bit is binary digit. So it's just a 0 or a 1. So if we have 4 bytes, that's really 32 bits. And we talked about that, and we talked about how much is actually stored. So 4 bytes of memory. Okay. There is an integer max value defined as 214748367, and an integer min value, right, defined as the negative version of that number. So that's the highest, the max and min value. What is that? Is that 2 trillion? Yeah. If you try to store any number larger or smaller than these numbers in an int variable, it will result in an integer overflow, right? If you try to stack too much stuff inside of a box, it overflows outside of it. And, you know, if we're storing something, we're storing data, and we've overflowed what the actual allocated memory usage is, we get an error, integer overflow, where an incorrect value could be stored. Try it below. Okay, so we're going to try messing with our computer right now, right? So this is our main method. We created an integer called ID, and we assigned it the value 214748365. And we wrote a comment, and it says overflow. So there were errors compiling your code. Error. Okay. Test overflow. It's an error. It's saying in Java line 5. This is how we can always look to debug our programs, by looking at the error. If we just see there's an error and be like, oh, there's an error, I don't know what to do with it. Or we can look at it and say, all right, line 5. Close in line 5. This is line 5 right here. Integer number too large. And it gave me the ID, and it's pointing right here. It's saying this one, you wrote too big of a number, right? What happens if I wrote 49? Yeah, number's too big. Okay, so also in line 6, it's saying that the integer number was too large. Okay, meaning that even though it was a very low number, it was too big to store. It says try to code below to see 2 integer overflows. Fix the integer overflow values by deleting the last 0. All right, so let's go ahead and delete the last 0. And let's run it. All right, and we're able to fix the overflow error. Okay, so think of you're putting things in a box. Usually, I make my wife. I don't make my wife. Usually, when we are decorating the Christmas tree, you know, it's fun. But then taking down the ornaments and putting them back in the box, I can never make everything fit. My wife is really nice at putting everything back in there. If I were to put everything back in the box, it would overflow. My wife stacks everything neatly and makes sure that everything gets back in there. I am not so good at that. Yes, sir.
Shouldn't the integer be able to hold 10 digits, not 9?
The integer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's take this number and I'll go ahead and store it down here and we'll run it. So that is the biggest, yes. So if I tried making this an 8, let's see what happens. Right, so it can take 10 digits there, but it was just saying delete the 0 off to be an easy fix, right? It wasn't saying that it could only have 9 digits there. It was just saying that that was a way you could fix it. But if you see my biggest possible number here, it allows me to write up to 214748365. But if I just added one more number to it, if I added a 6 on the end instead of a 5, it says, let me just rerun this. Gave me an error a minute ago. Let me rerun it. Okay, 6, 7. All right, so if I were to change this to an 8, it says there's an error. So one more number past there gives me an error. So yes, it can store 10, but it was just asking me, it says, fix the integer overflow by deleting the last 0 in the numbers to store less digits. So I just did that. Don't want to leave that error there, so I'll just take that off. All right, good question. Although it's not on the AP exam, you can format long decimal numbers to just show 2 digits after the decimal point with the following code. Okay, so if I go ahead and run this, it says run the code below to see how a decimal number can be formatted to show 2 digits. And this is something that I use pretty often when working with different data types in Python frequently. So you're able to format different numbers. And like I said, this is not on, we're not going to be testing on this, but it's just saying, hey, if you're interested, we have our main method. We have a double called number, 10 divided by 3. Okay. And then we print out that number, which is, it naturally stores it as 3 point, why does it do that? 10 divided by 3. Interesting. So I have this number and it's saying system.out.println, and then I use string.format. And if you want to actually format number into 2 decimal places, there's this prefix that exists. This is a format method that is passed 2 different arguments. And I don't want to confuse you guys early on here because we haven't talked about functions and talked about methods yet. But what this would do is it would take the number and convert it to 2 decimal places. The F stands for floating decimal point. So you don't need to know this right now. But it's just saying, if you were interested, don't get caught up too much on this. All right. What you do need to know is, does Java round up automatically when you do integer division? True or false? Does Java round up or does Java round down? Rounds down. It just takes off whatever decimal is off there. So I'm saying false, does not round up. See, Java throws away any values. True or false? Casting always results in a double type. Correct. It's false. Casting results in the type that you cast it to. If I want to cast to an integer, I can. Which of the following returns the correct average for a total that is the sum of 3 int values? Okay, so think about this. Which of the following returns the correct average for a total that is the sum of 3 integer values? So the correct average versus what it actually pops up. If I type in the total, right? Let's say I add in 90 plus 97 plus 82. I'll go ahead and add them up. 90 plus 87 plus 82. And I want to then divide that by 3. I get 86.3 repeating, right? So I would need to make sure to get the correct average, I would have to cast it as a double. Now, you have A, B, or C, okay? Now, if you look at this, we have our total divided by 3, and then we cast it as a double. We have our total divided by 3 and leave it as is, or we cast total into a double and then divide by 3. Which one do we think it is? Think it's C? To me, it's either C or A. Let's see. This will convert to a double value and then divide by 3 to return a double result. There you go. It makes sense to make sure that you're casting that ahead of time and not at the very end, because if you just did this in A, the problem with A is that it would give you the integer value and then just make it a double rather than taking the total and make it a double first. All right. 1.61 programming challenge, average 3 numbers. It says this would be a good project to work together in pairs. You don't have to, you can if you want, and switch drivers who has control of it after every line of code. In the code below, type in 3 made up int grades, so integer value grades, and then sum and average them. So add them up and find the average, find the mean. Use casting to report the result as a double. For example, if the grades are 90, 100, and 94, the sum of the three integers is 90 plus 100 plus 94 equals 284. And the average is the sum 284 divided by 3, which casted to a double is, that's a pretty good grade, 94.6. If you had that in your report card at the end of the quarter, it would round up to a 95. You should use your variables instead of the numbers in your formula. Follow the pseudocode below. So what is pseudocode? Pseudocode is just walking you through on what code should be written. Typically, if I'm about to write a program, I might just write out what I want my program to do in steps. It's kind of like code, but it's not real code. That's why it's called pseudocode. Type in 3 made up int grades and then sum and average them. Okay. Please paste your REPL link here to return it in. Okay, if you do your challenge in REPL. Okay, got it. All right, so the first step, it says declare 3 int values. So I'm gonna go ahead. My first one, grade 1. Well, first, I guess I got to write int grade is assigned the value of, I don't know, 89. And then I'll say int grade, I'll zoom in on this. Int grade 2 is assigned the value 91. And then grade 3. So I'll say int grade 3 is assigned, let's say they got better each time. We'll say 96. Pretty good grades. All right. Then it says declare an int variable called sum for the sum of all the grades. All right. Whoops. So I'm going to go ahead and do that. I'll say int sum is assigned the value of grade 1 plus the value of grade 2 plus the value of grade 3. Make sure to add a semicolon at the end. So I initialize my grades. Maybe, when you're writing a program, you're not declaring the value of the grade yet. Maybe that's whatever the user has put in. Then it says declare a variable called average for the average of the grades. All right. So I'm going to go ahead and do that. So I'll say the name's going to be average. And what it's going to do is it's going to find, well, I was going to go back and then ask you guys what you guys think it should be. All right. So if I have sum, the sum of all the grades divided by 3. Now it says declare a variable called average for the average of the grades. Okay. Now, calculate the sum of the 3 grades. Oh, I'm guessing it just doesn't even want me to put. It's not even asking me to add these up yet, I guess. Because down below it's asking me. They should just do it all on the same line, but oh well. Down here it's saying, then down here, write a formula to calculate the sum of the 3 grades. So I could say sum is equal to grade 1 plus grade 2 plus grade 3. Okay. And then it says write a formula to calculate the average of the 3 grades from the sum using division and typecasting. All right. So if we want to find the average, we're going to take the sum of the 3 grades, and it says dividing it, okay, using division. So we're dividing by 3. And how would I typecast this? What would I do? I'm asking you guys. But yeah, exactly. You could just divide by 3.0. This is probably what they want, right? They probably want you to just get used to that. Normally, what I would do is I would divide by 3.0, but that's just from experience of going through it. And then printing out the average. I also wouldn't have written this in all these lines of code. I just would have, as I declared the sum, I would have gone in and just done it right there, but oh well. Okay, so then we'll add our system.out.print line. Remember, print line as a blank line or starts the next line afterwards. And I'm just printing out the average. So I'm just going to type in average. All right. And in semicolon, maybe I made a mistake somewhere in here. Let's find out. I'll run it. And it says it passed. All right. So once again, just walking through slowly, I created 3 variables. One was called grade 1, one was called grade 2, one was called grade 3. All right. Found this, declared a variable called sum, declared a variable called average. All right. Then I changed its value. Well, I initialized it by taking grade 1, grade 2, grade 3, adding them up, taking the average and finding it by typecasting, put a double out in front here. You could have just divided by 3.0, but I think this is what they want you to. I think there's a lot of multiple choice questions will have this in there. So they want you to use that. And the answer is 92.0. We had a nice decimal there. Says your teacher may suggest you use a Java IDE like Replit. You can. That's great. So that way you can use the scanner class. If you want to know what the scanner class is, the scanner class allows you to receive user input. So if you want some more information on the scanner class, check this out. So like you can ask the user, enter your username, and then be able to store whatever the user types in by using a scanner. Now, on the AP exam and in this class in general, all the multiple choice questions, you will not be accepting user input. But if you would like to learn more, you can click there. When I teach in Python, when I teach in Java, typically I use and accept user input. But if I'm preparing students in the future to take the AP class, then you really don't need to. But in a real world application, you would use the scanner class. So if you're interested, you can move on and look at that. What's that? Okay, yeah. Here's a REPL template that you can use to get started if you want to try. If you get done early with this challenge, here's something else fun. Something fun you can do in Java, although it's not covered in the AP exam. Java is one of the first programming languages to use Unicode. It's an international standard that you can use. You know, a lot of you guys don't know the difference between. Some of you guys do, but don't know what hexadecimal means. Don't know how to convert from hexadecimal to binary to decimal to octal. We cover that actually in AP Computer Science Principles next year. So if you guys want to take AP Computer Science Principles, we cover conversion, decimal to binary, binary to hexadecimal. But not mandatory now. You don't need to know this. Okay. But you do need to know this. It says, can you print out a letter from 3 different languages using, or maybe you don't need to know that. I'm just going to run it. A in ASCII and Unicode is the decimal number. Yeah, you don't have to do this, but if you want to, you can. Okay, I'm not going to spend a lot of time on it because it's not mandatory. So once again, like if you're doing these things on your own and get caught up on this, you're like, well, I can't find the answer. Cannot figure it out. This, you don't need to know that. But if you'd like to, you can go back and play around with ASCII and Unicode. A summary of 1.6. Type casting is what we really did the entire time. Casting different data types. You can cast using int or double inside parentheses. It creates a temporary value converted to a different data type. Keyword temporary. Casting a double value to an int causes the digits to the right of the decimal to be truncated. We learned that Java naturally rounds down and just cuts off whatever decimal that you have. Some programming code causes int values to be automatically cast or widened to double values. So if you automatically have, if you start off with a 3.0 divided by an integer, it's going to automatically cast it as a double. Values of type double can be rounded to nearest integer by using int, right? And then also by adding 0.5 or subtracting 0.5 from negative numbers. Integer values in Java are represented by values of type int, right? We know that, we talked about that. It's stored in a finite, it's not infinite. There's only a certain number of, 4 bytes of memory that's actually able to use 32 bits. So there's certain values, there's a minimum value and a maximum value that we talked about. If an expression would evaluate to an int value outside of the allowed, so if it converts it to an int outside of the range, you get an overflow. Okay, we talked about overflow. This could result in an incorrect value. Okay. So mark as complete. It says completed. Well done. I've attempted 10 of 10 activities on this page. If you want to go back and look at ASCII, difference between ASCII and Unicode, you can. Okay. And you would click there to look it up. If you'd like to look at the scanner class a little bit more, if this is interesting to you and you'd like to accept user input, the scanner class is what you would be using. I typically in the past, when I taught honors Java, I had gone through and that was one of the first things I taught was the scanner class because it's nice to receive user input and be able to do things with it. All right. So that's 1.6.